Hello, my name is Sean Wilkins, and I am one of the authors for Pearson's Cisco CCENT and CCNA simulators. This video will take a walkthrough of a troubleshooting scenario lab in the simulator. Troubleshooting scenario labs add an additional level of complexity, requiring that you use your knowledge that you have gained from the Skill Builder, Subnet Exercise, and Configuration scenario labs to troubleshoot a number of problems that have been initially built into the lab. You have the option of following the steps or not, depending on if you want to perform the troubleshooting without assistance. Be aware, however, that the grading system is prepared for the commands that are issued in the lab steps and could show a grade other than pass if the exact steps are not followed. For this walkthrough, we will take a look at the VLAN troubleshooting lab. And let's get started by double-clicking on the lab name. Now that the lab is loaded, let's look at the three different window panes that are displayed. The first includes a figure showing the topology that will be used for this lab. Sometimes this figure shows only the devices and their connectivity, and some labs include additional information to help you complete the lab, like VLAN or addressing information. For this lab, the topology includes 4 different switches that are connected together with Ethernet links. Each of these switches then have a connection to a PC. The second pane includes a console window of the currently selected device. For this lab, PC1 is the initial device that is used. Because of this, it is the console that is currently being displayed in this pane. The third pane includes lab instructions. These instructions include tasks like documenting addresses, answering questions like asking for a student to determine a specific device or networking behavior, as well as steps that include the configuration of devices. Now that we have gone through the interface, let's walk through this lab. In this lab, each of the PCs are supposed to be configured into the same VLAN and on the same subnet. However, at the beginning of this lab, only S1 and PC1 can ping each other. Your job is to find the problems in the configuration that would cause these problems and correct them so all PCs can ping each other. Table 1 is used in this lab to keep track of the IP addresses that are assigned to each of the devices in the lab. Step 1 starts by asking you to connect to the console of PC1 and confirm the configuration matches what is shown in Table 1. To complete this, move to the console window and issue the ipconfig:\all command. This command shows that PC1 is configured with a 10.1.1.1 IP address with a mask of 255.255.255.0 and no default gateway. Keep in mind that since this lab doesn't contain a router, and all of the devices are supposed to be in the same VLAN and IP subnet, then a default gateway isn't required for connectivity. Like all other labs, the default password is always CS. Step 2 asks that you attempt to ping the other PCs shown in the topology. For this lab, the IP addresses configured for the other PCs are notated on the topology and can also be referenced from Table 1. The commands in this case to verify reachability are ping 10.1.1.2, ping 10.1.1.11, and ping 10.1.1.22. As you can see, the ping to 10.1.1.11 is successful, which is the address for S1, but the pings to S2 and PC2 are not. Step 3 asks that you move to Switch 2's console and log in. Step 4 asks that you display the status of the interfaces on Switch 2 and record the status of its connection to S2, Switch 1, Switch 3, and Switch 4. The Show Interfaces Status command can be used to display this information, as can the Show IP Interfaces Brief command. Either of these commands will indicate that each of these interfaces is operational. Step 5 asks that you find some information out about the interface that connects to S2. This is done with the Show Interface Fast Ethernet 0/11 switchport command. From this information, the step asks that you notate the operational mode and access mode VLAN. In this case, the interface connecting to S2 is in access mode and is assigned to VLAN 11. Step 6 asks that you display summary information about the VLANs that are configured on Switch 2. The command to do this is the Show VLAN Brief command. The output shows that Switch 2 has been configured with VLAN 1, the default VLAN, VLAN 11, and VLAN 12. Step 7 asks that you move to Switch 3 and determine which VLAN is assigned to the interface connecting to PC1. The output shows that the interface connecting to PC1 is configured into VLAN 12. From this information, you can determine that the interfaces connecting to S2 and PC1 are not configured into the same VLAN. To fix this, the lab asks that you modify the interface connecting to S2 into VLAN 12. Step 8 asks that you move back to switch 2's console. Step 9 asks that you get into interface configuration mode on the interface that connects to S2. Step 10 asks that you perform the reconfiguration of the interface as indicated in Step 7. Specifically, you will assign the interface into VLAN 12. To do this, the switch port access VLAN 12 command is used. Step 11 asks that you perform the original tests from PC1 to all other PCs. This is done by issuing 3 different ping commands. Ping 10.1.1.2, which fails, ping 10.1.1.11, which succeeds, and ping 10.1.1.22, which also succeeds. Step 12 asks that you record the problem that was found into Table 2. At this point, the lab will have you refocus in on the reachability problem with PC2. Step 13 asks that you move to PC2's console and confirm that it is correctly addressed based on the information shown in Table 1. To do this, it requires that the ipconfig:\all command be issued. This shows that the information is correct and that no default gateway is configured. Step 14 has you continue on PC2 and attempt to ping the other PCs. To do this, we use the ping 10.1.1.1 command, the ping 10.1.1.11 command, and the ping 10.1.1.22 command. As shown, each of these fails. Step 15 asks that you move to switch 4's console and log in. Step 16 asks that you display the status of the interfaces on switch 4 and record a status of its connection to PC2, switch 1, and switch 2. When using the show interfaces status command, the display shows that each of these interfaces is connected. Step 17 asks that you use the show interfaces fast Ethernet 0/12 switch port command to notate the operational mode and access VLAN for the interface. The display will show this interface connecting to PC2 is in the static access operational mode and configured into VLAN 12. Step 18 asks that you display a summary of the configured VLANs on switch 4. The display indicates that the interface connecting to PC2 is configured into VLAN 12 and that it is the only interface in that VLAN. At this point, it seems as though everything connecting to PC2 is configured correctly, as the interface is in the right mode, VLAN, and is operational. The next thing to focus on is how switch 4 sends traffic to the other switches. This is done with its trunks. The lab will now investigate if these trunks are configured correctly. Step 19 asks that you display information about the current trunks on switch 4. To do this, we use the show interfaces trunk command. The display shows that both the Gigabit Ethernet 0/1 and Fast Ethernet 0/1 interfaces are operating as trunks. Step 20 asks that you take a closer look at the output of the show interfaces trunk command. Does anything look like it may cause a problem with PC2 reaching the other PCs? If you read through the output, you will see that VLAN 12 is omitted from the allowed list of VLANs on both trunks. At this point, you have found the problem. If the trunks connecting switch 4 to the rest of the network don't allow traffic in VLAN 12, then traffic from the other PCs which are configured into VLAN 12 will never be allowed. The following steps will fix this problem. Step 21 asks that you move into enable mode, if you weren't there already, and display the current configuration. Take a look at this configuration and see if you can find a problem that would cause the trunks to not allow VLAN 12. As can be seen here, both the Gigabit Ethernet 0/1 and the Fast Ethernet 0/1 interfaces are configured to not allow VLAN 12 over them. Step 22 asks that you remove these commands from the configuration. To do this, first get into interface configuration mode for the Fast Ethernet 0/1 interface. From here, issue the switch port trunk allowed VLAN add 12 command. This command will add VLAN 12 to the allowed list of VLANs over the trunk. Now get into the interface configuration mode for the Gigabit Ethernet 0/1 interface and repeat this command. Once this is complete, exit configuration mode. Step 23 asks that you now redisplay the trunking status and verify that VLAN 12 is now part of the allowed VLANs on both trunks. As you can see, now VLAN 12 is allowed on both trunks. Step 24 asks that you move back to PC2's console and ping all other PCs on the network. To do this, we use the ping 10.1.1.1 command, the ping 10.1.1.11 command, and the ping 10.1.1.22 command. As shown, now each of these pings is successful. Step 25 asks that you document these problems' resolution in Table 2. This concludes the VLAN troubleshooting lab. To check your grade at this point, click on the Grade Lab button on the top of your screen. As shown here, each of the configuration commands that were issued are shown completed per device. When you are done viewing the grade report, exit by clicking on the black X on the top right corner. And with that, this concludes this troubleshooting lab walkthrough on Pearson's Cisco CCENT and CCNA simulator. I hope you enjoyed learning from it as much as we enjoyed making it for you.